Okay, this is some joint work BJ, Hees, and I are doing. We're calling it BGP TTL security hack, and it looks like something like this. Here's my agenda for this talk. Problem statement, is it useful? What are the mechanisms around it? What are the limitations around it? Maybe we can have some time for questions and comments. And if you want to see these slides for some reason, you can find them there. So the problem statement looks like this. We're starting to see DOS against the infrastructure, not starting, we are seeing DOS against the infrastructure, in particular against port 179. And how, the question about how and why this is happening, why, we know why, but how it's happening is pretty interesting. Actually, it's not that hard to do, right? The TCP4 tuple is easy to discover. The attack doesn't require a sequence number because why? Because once you get the packet onto the RP, you've accomplished your task. It doesn't matter if TCP has to dump it at that point. So you really don't care if the TCP is the segment is valid or not. You're just trying to overload the RP. So that's the nature of the attack. You don't have to own the router. You don't have to do anything to disable this. So what we were looking for is what we can do easily in the very near term. So not in the long term, SBGP, SOBGP, whatever, but in the near term that we can get our vendors to implement quickly. So the question is there anything short of crypto techniques or otherwise that we can use to mitigate these kind of attacks? And the observation is that TTL is still relatively hard to spoof, as far as I can tell. And so we wanted to know, well, can we somehow use that fact to build something that's useful? So is this useful? Okay, so here's how it works. Well, since the vast majority of eBGP peerings are between adjacent routers, there are some multi-hop, but they're mostly between adjacent routers, and especially the ones we're caring about right now. Why not just set the TTL on BGP packets to 255 and then just reject any of them that don't come from a TTL in the range 255 to 254? The reason for the range is because implementations treat what they do with the TTL on the directly connected network differently. It can be one or the other depending on the vendor. And so, if the received TTL is in a small range, let's say 254 or 255, and you accept it, otherwise you just dump it. That's the whole thing. And you might ask, why wasn't this done in the first place? And maybe somebody out there knows. I don't know the answer to that. Seems kind of obvious now, of course, given hindsight. So somebody asked me last time I talked about this is why not just set TTL equal to 1 and let TTL 0 do the discard that it will normally do? Well, the reason for that is that you can engineer it to be 1 when it hits that router, right? Because TTL decrement. So you can engineer TTL 1. The other one you can't. So a little more on the mechanism. You need the idea here is that we use a receive path ACL that allow the BGP packets to the RP if and only if they have the correct source destination and TTL. So in the range 255 to 254 for the directly connected peers. If the TTL is not in that range, just punt the packet into a low priority queue. Of course, that assumes you have those queues, and just discard it. So there's a few assumptions in the whole scheme here. One is that the pairings are between adjacent routers. I think that one holds up okay. This one's a little harder. It is common practice, or should be common practice, to ingress filter that have the provider's loopback addresses as the source of the IP address. That probably should be best practice, but I'm not sure that's too widely implemented. Also, we need to assume that the use of this mechanism, if we ever get it, is optional, and we can do it on a per peer group or per peer basis, and that the router supports a method for classifying traffic, i.e. priority queues. Both peer routers would have to implement this for it to work. That's pretty clear. So there's some serious limitations with this. Basically, it's kind of designed to protect the single hop session, except of course in those cases where the peer is owned, then you have to shut it down anyway. For multi-hop sessions like iBGP and multi-hop eBGP, it's less. You kind of trade off flexibility in the topology for the power of the technique. That's what you're kind of doing. So, I guess beyond this, we have all kinds of other proposals for how to protect the infrastructure. We're just looking for something we can do quickly and cheaply, and that our vendors can implement. So SBGP is one possibility. Go ahead. That's all.
Okay. For a multi-hop BGP for IBGP, could we extend this so that instead of actually running a multi-hop BGP session, run it over a GRE tunnel, in which case, after the thing gets decapsulated, still TTL of 255?
Yeah, you could do that. The other possibility is to just allow some kind of configuration where you know something about your topology, so you know something about the value or the range that the received TTL should be in. So basically, that would give you some flexibility, but at the same time, it would reduce your ability to protect against other kinds of attacks because just weakens the methodology.
Whereas the GRE tunnel is there and all rather supported, and
yeah,
there's.
Gotcha.
It doesn't require crypto.
But you can just spoof the GRE if you just put the TTL 255 packet inside, and there's no checking on the GRE packet, then it's
right.
You haven't solved anything.
Yep. You need to have the one hop thing there to get it. Go ahead.
One thought that occurs is for the multi-hop, you could actually have an agreement where the router that's legitimately sending it sets the TTL to some value you choose, and by knowing your topology, you know what the expected value at the other end is,
yeah.
And that would make it a little harder to spoof.
Yeah, we talked about a capability and so forth to do this, but we were kind of looking at how fast can we get protection, get some relief from this mitigation. Go ahead, Pedro.
So I see a bit of a problem on eBGP having a 255, 254 allowed values, because on eBGP you really want to make sure that those packets cannot get rerouted through an alternate path, while vice versa on IBGP you want to make sure that they can. So
right.
If you can't really nail it down to a single value that guarantees that the packet is actually staying on that link, because eBGP sort of has needs to have a link correspondence.
Right. This kind of corresponds to disabling the directly connected check. That's what you're saying.
That's what I'm saying, and that's something that has a significant cost.
Yeah. So what you have to do is you have to make the trade-off, right? I mean.
But then you need to really think. You need to really think about what the implications of that are, and potentially try to achieve that check some other way.
Right. Let me just keep going here a second. Oh, okay. So that's all I have. And I already got questions and comments. One thing I did want to say is we tried to find a home for this in the IETF, and IDR is not taking new work items, and we thought Domain was the right place, but Domain is kind of crumbling. So, pardon me? RPSec really isn't the right place for operational kind of things like this. We don't have anything. We really don't have a BGP ops or a global routing ops. So what we're doing is we're going to hold a BOF. I was calling it GROW because I was trying to find an acronym that was kind of cute. But this will be on Tuesday, IETF week, and please, if you have input for this, come along and help us out, see if we can make something reasonable out of it. That's all I have.